If the sum of an infinite decreasing GP geometric progression is given 3 and the sum of the squares of its terms is 9/2, then write its first term and common ratio. Let A be the first term and R be the common ratio. R be the common ratio, and it's an infinite decreasing GP, so consider to be mod R is less than 1, that is R lies between -1 to +1. Then sum to infinity S infinity we can write A plus AR plus AR square and so on up to infinity. So by the sum to infinity formula we can write A upon 1 minus R, where mod R is less than 1 and A is the first term. Let's consider in equation 1, and sum of the squares of the terms, sum of the squares of the terms can be taken as A square plus AR whole square plus AR square whole square plus and so on up to infinity, which is equal to, the sum is given 9/2, that is A square plus A square R square plus A square R power 4 and so on up to infinity, which is equal to 9/2. We can say that the left side series is also an GP, so that's an infinite GP. And since mod R is less than 1, that is R lies between -1 to +1, so which implies R square must be lies between 0 and 1. So we can consider to be 0 to 1, and so we can say it is also sum to infinity, and the first term is A square. So sum to infinity of the squares can be taken as A upon, that is A square upon 1 minus R square is a common ratio. So here the first term is A square and common ratio is R square, and sum to infinity we can apply since R square is, mod of R square is less than 1, that is 0 to 1 we can consider, and S infinity we can, and this is equal to 9/2 given. So we have A square upon 1 minus R square is equal to 9/2, which on simplifying, so we can write A upon 1 minus R into A upon 1 plus R is equal to 9/2, and since we have A upon 1 minus R, sum of an infinite GP decreasing GP is given 3, so which is given as a 3. So from the first one, since A upon 1 minus R is equal to 3, so let us substitute here 3 times of A upon 1 plus R is equal to 9/2, or we can write A upon 1 plus R is equal to, so here 9/2 into 3, so which is equal to again 3/2 we can write. And again, so cross multiplying, A is equal to 3/2 times of 1 plus R, and from here we can write A is equal to 3 times of 1 minus R, so we can substitute from, say this is second and this is third, from 2 and 3, we can write 3 times of 1 minus R is equal to 3 times of 1 minus R is equal to 3 upon 2 times of 1 plus R, or simplifying here 3 gets cancelled. So 2 times of 1 minus r is equal to 1 plus r, or we can write 2 minus 2r is equal to 1 plus r, or 2 minus 1 is equal to r plus 2r, that is 3r. So we can get r is equal to 1 by 3. Substituting r is equal to 1 by 3, or put r is equal to 1 by 3 in equation, say equation 2, so which implies that a is equal to 3 times of 1 minus r, that is 1 by 3, which is equal to 3 times of 3 ones are 3, 3 minus 1, that is 2 upon 3, which is equal to 2. Therefore we can say the first term is 2 and the common ratio is 1 upon 3.